All right, ladies and gentlemen, good morning and welcome to this little video on the simplex method and the introduction behind it. This particular problem that's up at the top of these notes, this particular problem isn't too bad to do because we can still graph to solve. And the reason we can do that is because there are only two variables for that particular problem, and those variables are x1 and x2. And instead of x and y, I can have x1 go down the x-axis and x2 go up the y-axis, and I can handle it that way. Okay, so I'm not going to really solve this problem here, but what I am going to do is draw your attention to this one down here, which says we can move away from graphs and start to use matrices in order to solve this problem. You notice that we've got a farmer that's got 100 acres of land on which he wants to plant a mixture of potatoes, corn, and cabbage. There's a cost associated with each one, and there's also a profit associated with each one. So here's a profit of 120 on the potatoes, 40 for the corn, and 60 for the cabbage per acre. So what I can do is I can use this information to find an objective function. So I might have z is equal to 120x1 for the potatoes, and then 40x2 for the corn, plus 60x3 for the cabbage. Okay, so there's my objective function, but I also have some constraints here. And the first constraint I see is I only have 100 acres of land. So if I know that information, then x1 plus x2 plus x3 all has to be less than or equal to 100. I also notice in rolling along and rereading the problem, I've got a maximum of $20,000 to spend. And here are some costs that are associated with that. So another constraint is going to be, let's get the right tool here. Another constraint is going to be 400x1 for the cost of the potatoes, 160x2 for the cost of the corn, and 280x3 for the cost of the cabbage. And all of that has to be less than or equal to $20,000. So this problem looks not too bad to set up, except we've got three variables. So trying to solve this by graphing is going to produce a big mess. Graphing is going to make a really big mess here because we're not going to be able to graph in 3 dimensions. I really don't know of an efficient way to do it. And I haven't run across any software that's going to do it efficiently for us. And that's going to be just really challenging to try to do, especially if you're somebody like me and has bad depth perception and you just can't see what's going on. So how are we going to solve this problem? Well, what we're going to do is we're going to look at this thing called the simplex method. And the simplex method, as I mentioned in class, was created by George Dantzig, who was really, really smart. Awarded the National Science Medal by President Ford in 1975 for his work on helping to allocate resources for the Air Force. Stanford mathematician, just really, really brilliant man. In order for us to do the simplex method, we need to do some fixes on our problem to make it work. And one of the big fixes that we need to look at here is matrices work better with equations as opposed to inequalities. And those constraints provide a whole bunch of inequalities for us to look at. Okay? We also need to make sure that the problem is in what we call standard maximum form. That means the objective function is to be maximized. Well, we're trying to maximize profit, so check. All the variables should be non-negative. Well, they've got to all be greater than or equal to 0. That's non-negative, so check. And if you look at your notes from the previous page, you'll notice that all the constraints expressed as variables have to be less than or equal to some number, and that too is going on. Check. So yes, our farm problem is indeed in standard maximum form, and that's really the way that you want it for the simplex method to work and work very well. Okay? So now this is kind of the challenging part right here. The simplex method will make us convert our inequalities into equations. In order to do so, we need to add in something to quote-unquote pick up the slack in each constraint. Now, I want you to go back to that bicycle problem that we did on the spreadsheet in class. That problem is one where we had to take a look at, if we spend so many labor hours in one department, then I've got some left. Well, any unused resource is called slack. So I'm going to go ahead and call this an unused resource. Okay, so in this case, if we have any budget money left over from buying the plants in the first place, or if we have any acreage left over that we haven't planted yet, that's going to represent my slack. Okay, so we're going to use one slack variable for every constraint, and they have to be non-negative. Okay, so the way this now looks is that I'm going to have a slack variable added in for our farm problem. So the first one has to do with the land. Okay, so if you remember, that constraint was x1 plus x2, oopsies, plus x3. And in order to make that an equation, I need to add in my slack variable s1. Okay, so basically what this means is all of my acreage for the three different crops put together, plus whatever I didn't use. Okay, so let me highlight that one more time. All of this acreage that I'm using, plus what I didn't use, has to equal 100. So say that all of this has to add up to 70. Well, then your S1 is 30. Let's say all of these three acreages for the three different crops add up to 90. Well, then your slack would be 10. Your slack is indeed a variable because it's going to basically pick up the slack and get you to your 100 here. Okay, so I'm going to have to remember what that other constraint was here. And as I remember that constraint, it is going to be 400x1 plus 160x2 plus 280x3, and I'm going to put in a separate slack variable s2 here, and the reason why is because that slack variable can take on a different value. So this s2 represents the money we didn't spend. So all of this right here, this x1, x2, x3, that all represents what we have spent. The slack variable represents what we haven't spent of our $20,000 budget. So that's kind of a quick little understanding on slack variables. Okay, now I need to do something with my objective function too. I need to get it so all the variables are equal to 0. And the easy way to do that is going to be to take all of our objective variables, our objective functions variables, and move them left with the z. So if I move all those variables over on my objective function, it becomes negative 120 x1 minus 60 x2. And I'm going to change that back here. That should be 40 x2 because that's the right number here. So minus 40 x2 minus 60 x3 plus z is now equal to 0. So that's how that works for setting up our simplex method problem from the farm issue. Okay, so now our problem is finally ready to be solved, and what we're going to do is convert this into a matrix. There's way too many variables here, so we're going to set up what is called a Simplex Tableau, which is a fancy word, that table, fancy word for table, and it's going to organize everything. So across the top row, we're going to leave write out a spot for each variable, but leave a small space in between. So for our Tableau, we have 3 variables, x1, x2, and x3. We have 2 slack variables, s1 and s2. Those come next. And then we have a z. Okay, now for our first row, we're going to take our first constraint and write out all the coefficients below their respective variables. So the first one was x1 plus x2 plus x3 plus s1 equals 100. So we're going to put those coefficients there. And I didn't have any s2s and I didn't have any z's, so I'm going to put those in as 0. Okay, and then we're going to put a little vertical bar here, and we're going to write out 100 to represent the limit of our land. Okay, so now we're going to do the same for our cost function here. And for that cost function, it was 400x1, 160x2, and 280x3. I didn't have any S1s, but I did have an S2, and 20,000 was the limit. Okay, so now you're going to keep going until you reach your last constraint, and when you're done, you're going to put a horizontal bar underneath, just like this. And then the last thing we're going to do is take that objective function that we rewrote with all the negatives and put it in the bottom row. And to put that in the bottom row, I do a -120, -40, -60. There's no S1s, there's no S2s, there is a Z down there, and that was equal to 0. Okay, so that's how you set up a Tableau for the Simplex method. It seems a little abstract and complicated right now, but now that we have this all set up, now I can work on some more vocabulary to try to understand it. Okay, and there's 2 different types of variables here called basic and non-basic. A variable who has exactly 1 non-zero entry, that's a basic variable. So in the case of our S1 and S2, those have basic variables as part of their solution, or they're basic variables because they only have one particular non-zero entry right here for S1, and everything else is 0. So I'm going to go ahead and make this a basic variable. And S2 is also a basic variable because it has only 1 non-zero entry. Now, Z is always a basic variable, and if you do this right, it's always going to stay a basic variable. But the others are not, because you've got all sorts of non-zero entries in each column. Okay? And now we have a basic feasible solution that corresponds with a corner point, and it only comes from basic variables. Well, how do you read that solution? Well, let's see if we can take a look at that real quick. Okay. Reading the basic feasible solution from a Tableau is pretty easy to do. You're just going to go write down each variable, and you're going to identify if it's basic or not. We're only going to pick the ones that are basic. Anything that is non-basic automatically gets assigned a value of 0. So let's take a look and see how we can pick the solution out from this problem. First, let's focus on just x1, which is right here. And you notice that it's non-basic because we've got more than 1 non-zero entry. So I'm going to go ahead and say that x1 is equal to 0. I just assign it 0 since it's not basic. Okay. Now, if you take a look at x2, it is a basic variable because there's only 1 non-zero number in that column, and that's this 5 in the second row. So how am I going to figure out how much x2 is worth? Well, what I'm going to do is I'm going to take that 5 and I'm going to divide it into this right side number of 45, and then that means that x2 is going to be 9, just like that. Okay, so let's go to the next column, and I notice that x3 has a bunch of non-zero numbers in it, so I'm just going to assign it a value of 0. S1 also has a couple of non-zero numbers in it, so I'm going to assign it a value of 0. And now we come to S2, and S2 is a basic variable, and the reason why is because we've got one non-zero entry here. So if that is the case, that I've got one non-zero entry right there, well, then I need to divide that into that right-hand number. So S2 is going to have a value of 17, oopsies. This is going to have a value of 17 divided by 2, or 8.5. Okay. All right, so one more, and I now come to this z right here, and my z, my objective function value, can be found as well. And that can be found by realizing it's a basic variable. So I'm going to take this 3, divide it into 90. And that's going to get me an objective function value of 30. Okay, so that's how you read those. So before we move any further, we're going to hit the pause button right here, and I'm going to have you see if you can try to set these up, and we will come back and talk about these tomorrow in class and see where you are with them.